Hello everyone. So in this video, we'll learn about what are classes in JavaScript and how do we implement classes in JavaScript, what is prototypal inheritance, and how it is different from the classical idea of inheritance. So let's first look into what is the classical idea of inheritance and how classes work in a traditional object-oriented paradigm. So this is just a disclaimer. This is not how it works in JavaScript, but first we are discussing on how classes generally work in traditional object-oriented paradigm. So suppose we have a class A, and this class A has some properties X, Y, and Z, and it also has a function F1. Uh, Now we can also have a child class. So A is being parent class, and we can also have a child class B, and B has two properties of its own, I and J, and we also have a function F2, and B inherits A, or B extends A. Now if we instantiate objects of B, then these objects, say we instantiated an object B1, these objects will hold all the properties of B that are I and J, and they will also hold all the properties of A that are X, Y, and Z. And it will also hold all the functionalities that D and A have to offer. So this object B1 will have function F1, and this object B1 will also have function F2. And considering this, I can call any of the property from this object B1 using b1.x, this kind of syntax, b1.I, or if I have to call a function, say b1.f1 or b1.f2. So this is how we can use object b1. In similar fashion, we can create more objects from this class B. Say we created another object b2. It will again have all the properties that were there in A and B and both of the functions as well. Now think here to observe and understand is classes are no entity in their own. Classes are just an idea of how an object should look like. Say we instantiate an object directly from class A. Let's give it a name A1. Then it will only have these properties and the function that we have in A. So classes are just ideation of how an object looks, but they are not actual physical entities that reside in memory. Classes reside in memory as code, but they do not reside in memory as the objects reside. So objects that we see around are the actual entities that are there in memory and that hold space that we can use. But these classes are just blueprints for those objects. And when I call this object b1.f1, when I call this function f1 on b1, this function has nothing to do with this class A. It won't go back to class A and check, okay, what is the implementation here? This is how I have to work. Okay, I'll work. No. This B1 will hold an implementation of F1 in itself, and it will use what it needs to use. So it won't go back and check in class A because there is no object or there is no real entity as class A. What's there in memory is this is the object. So B will have all the information that it needs. Similarly, B2 will also have all the information it needs, and A1 will have all the information it needs. And how this inheritance works is whenever an object is being created, when we instantiate a new object, then we we look at all of our parents and gather all the properties and functions that are needed to create an object and then create an object. So if you look at it in this way, there is a clear top-down relationship that you can see. Class A is the parent of class B, and if we have more child, say there is a class C somewhere which inherits from B and extends B, and there might also be a class D that can also inherit class B. So there is a top-down structure that is created. This is how the idea of classes work in traditional object-oriented paradigm. Now let's look into what are the similarities of this concept that we use in JavaScript and what are the differences that are there. So previously we talked about that whenever we have to create an object, we'll have a class, and then only we can create an object, because class is a blueprint of an object, and without a class we won't have an object. But in JavaScript, the idea is completely different. I can create an object simply by writing this syntax. We don't need to have a clear idea of how an object should look like before creating it, and we can anytime modify that object, the structure of that object, and at any point in time we can change whatsoever we want that is residing inside that object. We can delete properties, we can add new properties, we can create new functions, whatever we want, we can play around with it. So point one that we can note here is there is no such need of a class, because we already have objects and we don't actually need a blueprint. But if we would need a blueprint, then the question is why? And if we would need a blueprint, then the question is why? So a simple answer to that is, if we need to create a blueprint, it should be because suppose you have to create a certain type of object again and again and again. You have to create 30 objects that have same properties, 30 objects that have same properties. So you might be iterating over certain properties again and again in a for loop, or you could be doing some fancy stuff to do it. That is somewhere will need a blueprint kind of thing to hold the idea of an object. But in JavaScript, we don't have anything as such as class. So what we do is we create constructor functions. We create constructor functions. Now, what is a constructor function and how do we implement them? This will look into the to quite depth in further lectures. But for now, what we can understand is how to create objects in classes. We create objects in classes using constructor functions. And constructor functions is just one of the ways that we can utilize to create objects. Apart from this, we can also create objects by simply adding this syntax, normal syntax. And we can also create constructor function using the class syntax that we have. Okay, not constructor function. We can also create objects of a particular type having a particular set of values using class syntax that we have in JavaScript. So these are three popular ways that we can utilize. But the question that arises here, okay, we have a certain way of creating an object, and now what we are able to do is we are able to create objects again and again. What we are able to do, say I need an object that has three properties, two properties, size and weight. And what I have done now, I have figured out a way that is constructor function. For now, say we have figured out a way that is constructor function. And using this constructor function concept, we can again and again create this object very quickly. We won't have to write a lot of stuff. Then weight. So I'll say it S and W for now. So we don't have to write it again and again. Size and weight. And we have a way called constructor function using which we can create it quite easily. So I have to create 30 objects. I can create 30 objects. Now, one of our problem is, so why did we needed classes? We needed classes so that when we create an object here, we will have an idea that what properties object will hold. What was the second thing that was needed? We should also have a way to define the properties. To define the functionality that this object will have. So say this object V1 will have functionality F1 and F2. That comes from a inheritance model. So if I create an object of B If I create an object of B, then that object should also have all the properties of A and all the functionalities of A. But right now, when we look at our solution that are coming from, we said that we have constructor functions, and what constructor functions can do is they can create similar objects again and again. But we do not talk about what we do not talk about is how are we going to implement this model of inheritance. Because if I created this object, then how this object will have any similarities with a different object or with a parent object? How we can handle this? In JavaScript, every object has a special property that is called prototype. And what does this special property does is it acts as the parent of an object. So what do I mean when I say a prototype acts as the parent of an object? Say this is our object X. This is our object X, and it has a prototype value, and it has a property prototype proto. So that's how we reference. That's not exactly how it is stored, but for time being, we can say that it has an extra property proto that represents the prototype. And now we can link this prototype to a different object. Say we link this property to a different object that was product. So that was product, and what product had is product had name and say also cost. And now what we do is we link this proto to this object product. See what the difference here is, that this object that we are talking about is an actual object. This product object will be an actual object in memory that will hold some space. And this object X will also be an actual object in memory that will hold space. And now if I try to reference X dot S, what our code will do is it will go X, we'll see. Do we have something like S here? Okay, yes we have. Whatever value is there, it will give us. So say it has a value 7, will give us. But if I access something that is not there in our object, say name, what it will do is say we have this property name. What it will do is it will check, okay, I don't have anything that has this identifier name, but I have a prototype added to me. So let's check if my prototype has any value with it. So it will go back to my prototype, and it will say, hey product, do you have anything that has an identifier of name? Yes, product will say Yes, I have something that has an identifier of name, and what it is a table. It is a table. Sorry, and it is this value, table, and this will return table to us. Now, if you look at it, what's the difference in the traditional model of object oriented programming and here what we do in JavaScript is here in traditional model this was our actual product. This was our actual object, and this object itself had all the properties within itself, right? It had all the properties, all the functions that it needed within itself. It had I, J, K, X, Y, Z, and whatnot. And it also had function 1, function 2. Everything was stored in the final object. But when we look here, this is object that we are talking about in JavaScript. That is the current object. And this object has only two values, S and W. And it links to the parent object that has actual existence in memory. And those values are not copied here. Those values are not copied here, and they can be copied via some mechanism if we need them. That is a different debate. That is a different part of implementation. But those can be copied here if we need them. But these values can reside in a complete different object, that is the parent object, that we also refer as prototype of this object. Prototype of this object. So what is a prototype? Prototype is the base object using which we can create new objects. So if we try to understand what is a prototype, we can say prototype is a base object. Say now let's think about it again in a different manner. Say we have to create a hierarchy of fishes where we have a class fish which can swim, and we also have to create different subclasses of fishes. Say we also have to create sharks and jellyfishes, and this thing called shark will have all the properties that a fish has, plus it will have all the functions that fish has. So mm, let's try to see how we can implement such kind of a scenario using this prototypical inheritance that we just discussed. So first of all, we'll create an object fish. So let's say we have an object fish, and fish should have some properties. So what properties a fish should have? It should have an age. It should have some weight. I'll denote weight by W. So and all these properties, where I'll keep them in constructor function. What are constructor functions? We'll talk very in much of depth in later videos, but for now we can say constructor functions help us to create similar looking objects again and again very easily. So constructor function will help us to create uh, an object that contains age and then that contains this value weight. It will help us to create kind of objects again and again. And we'll also, apart from this constructor function, to create fishes, we will need a prototype. So what a fish can do, what all fishes can do, all fishes can swim. So in the prototype part, we'll say that fishes can swim, and we will implement this feature of swim within the prototype object. So this prototype will itself be an object. This prototype will itself be an object, and it will have this function swim. Okay, and apart from this object prototype, we have a constructor function. And what is the work of constructor function? Work of constructor function is to create an object with these two values again and again. Now, what we actually do is, when we create an instance of fish, when we have to create an instance of fish, what we do is we create a new object. We create a new object. Say we created a fish named Nina. What we do is create a new object with all these values. Nina has an age of 2 years and it has a weight of 1 kg, and we assign this prototype to this object, to the prototype value that we have predefined. Okay, we assign this prototype here. Now, whenever I say Nemo.age, what we do? We go to this object, see that there is a property age, and we get the value. That there is a property age, we get the value. Whenever I type Nemo.weight w, we go to this object, we see we have a property w, and we get the value. When I try to call this function Nemo.swim, what happens is, we go to this object, we see there is no entity with the identifier swim. Now what we do? We see we have a prototype linked somewhere. We go to the prototype and it will say, okay, prototype has something called swim. Now we can use that function and we can create multiple fishes. Say we created another fish, Dory. So Dory will have an age. Dory was 5-year-old, has a weight of 3 kgs. Pretty small fishes we are talking about. And it will also have a prototype that links to the same prototype object. And this object is also there in memory. This object itself there in memory. So whenever I say Dory.swim, what it will do is it will check Dory has something called age, Dory something called w, but there is no swim function defined within this object. Then we'll iterate to the prototype of Dory, and there we can find this function swim. So what is a prototype? Prototype is the base object which on top of which we can create new objects, and these new objects that has a prototype linked to them has access to the properties of their prototypes. So Dory has a prototype. We'll give this prototype some name. Say we'll call him fish dot prototype for now. Fish dot prototype prototype. We call them fish dot prototype for now. So Dory has this prototype that is fish dot prototype, and Nemo also falls back to the prototype fish dot prototype. So all the properties, function, and everything that we define here will be accessible to all the objects that are linked to it. And we can, and there is no limitation that we hold that Dory can have a prototype only if it has an age and a W value. We can randomly create an object without help of this constructor function, and we can assign this prototype of this object to fish.prototype, and it can also access function swim if we need to. So here we checked what is the how what is a prototype, how a prototype works, and how it is different from what we had in traditional method of implementing classes. In traditional method, what what was the way go is that classes, they had no actual existence in memory, but they were just ideas how an object should be implemented. But here in JavaScript, we don't have classes, but we have base objects. So we had a base object on the top of which we created new objects. We had base object fish.prototype, and on top fish.prototype, we created a new object Nemo, a new object Dory. And since we created these objects on the top of a previous object, these new objects will have access to all the properties and functions that were linked in this prototype object. And this is how we share functionality in JavaScript. And this is a different approach, that I can also make this constructor function in such a way that all these functions that I define in this prototype will be copied to Nemo again and again. But that will be a very hefty thing to do, because we only need one implementation of this function swim. We don't need to copy it to every object again and again if we are to have same code everywhere. So it's also memory efficient if we do it this way. Now let's see how inheritance works and how we can implement inheritance in while achieving all these things using a prototype. So if we have fish, then we can also have different kinds of fishes. Sure. So let me just clear it up a little. There should be a way to increase size of this eraser. Yeah. So we had a fish. So what we are saying a class is a class in JavaScript we don't have classes, but we have similar structures. And we are just we are not trying to imitate anything, we but using the class syntax, what we actually do is we we give we create a mirage around these concepts only, and classes are actually implemented in this way only in JavaScript. So we'll understand how inheritance will work. Say now I have to create a different kind of object, that is shark. And shark is also a fish. So shark should also have all the properties that a fish will have, and it should also have all the functions that a fish can do. Okay. And shark will have its own properties as well. So how the constructor function will work here? First of all, say this constructor function had a name. First thing that this constructor function of shark should do is it should call the constructor function of fish. So first of all, what the constructor function of shark will do is it call the uh, constructor function of fish, because we have to create a fish to have a shark. Okay. And then it will add other properties to this value. Say shark will have a property kills. That is the count of people the shark has killed. Pretty dangerous shark. And this is not an actual object. This is a function that will create an object with these values. It will have values that come from fish, and it will call a function that is there for fish, and using that it will create it, and it will also have a new value fish. Apart from this, sharks can do something as well, right? Pardon? Sharks, say sharks can murder people. So shark will have a function murder. So let's call it in for now. And this is a common functionality that every shark will share. So we can keep it in the prototype object. And prototype is itself an object that all sharks will link to. So say we create a new object shark using this constructor function, say s, and we create a new shark. Let's give him some name. Again, let's reuse the name Nemo. And Nemo is now a shark. Pretty difficult to imagine, right? Nemo is not a shark, but Nemo is a shark. So where should the prototype value of Nemo should link? Prototype value of Nemo should link here. And since Nemo is a shark, it will have values of all those values that fishes have. Age will be there, and W will be there. Kills will also be there. But do you see any problem right now that we have? We have a problem. And what problem we have? That this prototype can only point one thing. Either it can point this object or it can point this object. So what should I point? If I point this shark prototype, then we have this function murder that need to have that Nemo needs to access. But in this case, it won't access this function that is swim. Now this leads us to a problem that we cannot link it to two things, but we somehow want Nemo to access all the values that are here as well. And if we link, and we definitely will link it here. We don't want Nemo to be linked anywhere else because Nemo is a shark. And if there is a prototype for shark, then we'll link prototype value of Nemo will to the shark's prototype. In such case, what should be the ideal way is that we link this prototype object's value to a fish prototype. Boom. Now see what will happen. If Nemo calls Nemo dot murder, it will check, okay, I don't have any value with M identifier. I don't have any value with M identifier. No. Then it will go to the prototype. Okay, here is the value for M modifier, and here is its definition how this function should work. I can execute. Similarly, when we'll call Nemo dot swim, what will happen? It will say, I don't have swim function, I don't have swim function, I don't have swim function. Let's go back to our prototype. It also doesn't seem to have a swim function, but here is one more prototype. Let's go back to the prototype. Okay, here is a swim function and we can utilize this. So this phenomena of going one prototype to the depth of two where there is another prototype, and probably fish is something that is linked to another. Say fishes can be living beings, right? There is some hypothetical class that was there, living beings. It can be linked to the prototype of living beings, and living beings can be linked to anything that exists, or any number of classes can be there, is what my point is. So it creates a chain of prototypes. This is what is known as prototype chaining. Whenever we have to look for a property within an object, what we do is we first check within that object, then we check within its prototype. Then if there is a prototype that is linked, we check in that prototype, and we go on till this prototype chain ends, points to null. By default, if we create any object, then it will have a default prototype of object. So if we do this, let A is equals to an object, then by default it will have an prototype of capital object. Object. That is the universal prototype that every object will end up to. And what object will point to? It will point to null, because somewhere it has to end, right? Prototype of object will end to null. So let's see again. So now we have discussed what are prototypes. Prototypes are actually base objects on top of which a different object is created. And that new object can access say this, can access all the values that it contains, and it can also access all the values that its prototype is having. Say if its prototype is having some values, and not just functions. Prototypes can also have values that we already discussed in the first point. When we were discussing this, we discussed how a prototype can also share values. So we linked a prototype of X to some product object, and when we said X dot name, name was not here, so it checked in the prototype and name was there, so it could access name from there. So we can not only share functions, but we can also share values. We can also share other things that object hold, and how we utilize. So this is the whole concept of what prototype is, and the way this prototype chaining helps us to create this model of inheritance is known as prototypal inheritance. And in further videos, we'll see how we can use this model to actually implement this prototypical inheritance. How we'll actually implement it using code. Let's summarize what we looked quickly. We looked that what is the traditional model of object-oriented programming and how inheritance work in that model. In classical paradigm, objects will hold all the values it will need. There is no concept of a previous object that it is linked to, and that's how it works. But in JavaScript, how, how it actually works is that we have an object and we can link that object to another objects using a special property that is prototype. And this prototype, and our object can access all the values that are stored in the prototype, and we leverage this functionality to implement inheritance. And this sort of inheritance, we call it prototypal inheritance, because our object inherits all the values that are there in its prototype, and its prototype and so on. And this chain that is created between prototypes is known as prototype chain. So let's see in next video how this work, and let's see some practical examples before we head to implement something on our own.